Let's review transmutation via radioactive decay. In an earlier lesson, we stated that when atoms transmute via radioactive decay, radiation in the form of energy or particles is emitted, without the need for some type of inducement to do so by bombarding the nuclide with something else. Such transmutation modes of decay include alpha, beta, and gamma emission. Here, we investigate transmutation when a bombarding, i.e. a bullet particle, causes it. In transmutation via nuclear reactions, we have an inducing particle, a bombarding particle, a bullet. Typically we have two reactants and two products that are in these reactions. We have a target nucleus, we have a bombarding particle, in this case it's an alpha particle. Then we have usually some sort of small ejected particle, in this case a neutron, and then we have a large product nucleus, in this case phosphorus 30. You can see that with all nuclear reactions, the mass on top balances on both sides of the reaction. In this case, the mass is 31 on both sides, and the charge is 15 on both sides. We could abbreviate this reaction like so, where the large nuclei that are involved are on the outside, the target nucleus on the left, the product nucleus on the right, and in the middle a set of parentheses with some sort of symbol for the bombarding particle on the left side of that, and then any ejected particle that's on the right. Ernest Rutherford was actually the first person to artificially transmute elements in this fashion. Let's predict the missing species and write the shorthand. If we look at the masses, we see that we have a total mass of 28 on the left, so we're going to need a total of 28 on the right, which means the mass number here should be 4. On the bottom left 13, so far 11 on the right, so then we need a 2 on the bottom part. This is an alpha particle. And then we abbreviate this by writing the target nucleus first, the main product nucleus on the right side, and in between a set of parentheses symbolizing the bullet particle and anything else that comes out, in this case the alpha particle. Let's predict the missing species and write the equation. Here we're given the abbreviated version of the equation. Let's go ahead and write that out. We have nitrogen 14, an alpha particle, which we can write 4 over 2 He because it is a helium nucleus, or if you want to put the alpha symbol there, that's okay too. A proton is simply something that has a charge of positive 1 and a mass of 1. I wrote it with an H, but you could put a lowercase p there as well. What must be the other species? The total mass on the left is 18, which means the mass of this species has to be 17. The total charge on the left is 9, which means the charge of this species has to be 8. With a little reference to the periodic table, we see that element 8 is oxygen, so the missing species was oxygen 17. Particle accelerators are used to accelerate charged particles, like alpha particles. We cannot accelerate neutrons, but we can use neutron emitters to produce artificial isotopes. Often beta emission follows neutron absorption. The reason we can't accelerate neutrons is because they don't have any charge. But what we can do, for example, is bombard uranium-238 with neutrons, and when a neutron is absorbed, it of course turns into uranium-239. Uranium-239 is a beta emitter. In doing so, it transmutes into neptunium-239, which is also a beta emitter, and will transmute into plutonium-239. Why do we care about this? We care about this because uranium-238 is rather plentiful, but it's not fissile, which means it can't sustain a nuclear chain reaction. Plutonium-239, on the other hand, is fissile. It can sustain a nuclear chain reaction. Here we're producing more plutonium-239 out of the rather plentiful uranium-238. Let's summarize. Transmutation is the process of atoms changing into other types of atoms, or, alternatively, nuclei changing into other types of nuclei. In radioactive decay, transmutation occurs spontaneously, without bombardment by an outside particle. In a nuclear reaction, on the other hand, transmutation of an atom requires a bombarding particle. Sometimes transmutation via a nuclear reaction can trigger other spontaneous radioactive decays, as when non-fissile but plentiful uranium-238 is transmuted into fissile plutonium-239.